Hello everyone and welcome to today's lesson, Oxidation and Reduction by Chem with me. Let's start with the definitions. Oxidation is defined as the loss of electrons from atoms of a substance, and reduction is defined as the gain of electrons by the atoms of a substance. As you can see by the half reactions, Cl gained 2 electrons, but it became more negative. That is why we call it reduction. That's why we call it why it has reduce in reduction, because its charge decreased. However, in oxidation, which is the loss of electrons, it lost an electron and its charge increased. Oxidation and reduction are complementary reactions, meaning you can't have one without the other. Why? Because when you lose an electron, or when an atom loses an electron, another atom has to take it. It can't just disappear. It can't just go into nowhere. Another atom has to accept it. So oxidation and reduction always occur together. These reactions are called redox reactions, or oxidation reduction reactions, which involves the transfer of electrons from one atom to another. An oxidizing agent is a substance that oxidizes another substance by accepting its electrons, and it is reduced. However, a reducing agent is a substance that reduces another substance by losing its electrons, and that is oxidized. So we said that when an atom loses its electrons, another atom has to accept those or gain those. The one that gains them is called an oxidizing agent, and vice versa with the reducing agent. So the oxidizing agent is always reduced and the reducing agent is always oxidized. Scientists use oxidation numbers as a tool to keep track of the movement of electrons in a redox reaction. And oxidation reduction reactions feature changes in oxidation numbers. There can't be a redox reaction with absolutely no change in oxidation numbers. So the oxidation number is the number of electrons that are lost or gained, and it is equal to the charge of a monatomic ion. So in oxidation, the oxidation number increases, and in reduction, the oxidation number decreases because it's equal to the charge. So these are the rules to determining an oxidation number of an element. They may seem a little hard, but they're easy once you get used to them. When you do these, you have to do them in order of priority, or you have to do them in order. You can't just do them randomly. So you have to kind of make a checklist and go from rule 1 to rule 5. So rule 1 is an uncombined atom of an element. The oxidation number for it is 0, such as in Al, it's an uncombined element, meaning that there are no elements bonded to it and no elements near it, so it's equal to 0. But for monatomic ions, the oxidation number is equal to a charge, such as in Al3+, where the charge of Al3+ is +3. Rule 2 states that fluorine always has a charge of -1. Group 1 elements have a charge of +1, for example, Na. Group 2 elements have a charge of +2, for example, Ca, and aluminum has a charge of +3. In the explanation, you can see that fluorine equals -1. Okay, so Rule 3 states that hydrogen has an oxidation number of +1. And Rule 4 states that oxygen has an oxidation number of -2. For hydrogen, the exception is if it's with metal, and for oxygen, the exception is if it's with fluorine or a peroxide, which means with metals and hydrogen. Step 5 is one of the most important rules, it says that the oxidation number of an element that is not mentioned above, or the last element, which is usually the last element, you equal the sum of the oxidation numbers to 0 if it's a neutral compound, meaning it has no charge, or you make it equal to the charge for polyatomic ions. And if two elements have unknown oxidation numbers, the more electronegative element has the oxidation number or the charge of the monatomic ion. So you can see in the example that I put that you saw the oxidation number of oxygen, which is -2, and then you made Cr's oxidation number X, and you added them together. You have to not forget to multiply by the amount of atoms. So oxygen has 4 atoms, so you multiplied -2, the oxidation number, by 4, and added X to it and made it equal to -2. Why? Because it's the charge of the polyatomic ion, which is the example. So once you apply basic math steps, you'll realize that the oxidation number for Cr is +6. This is an example of electronegativity. The higher it is in the group, the more electronegative it is, and the more to the right it is, the more electronegative it is. So the closer an element is to fluorine, which is which is I think the most electronegative element, the more electronegative it is. These are a list of common polyatomic ions that you should know the charges of. Like you can see the -1 charge polyatomic ions, the -2 charge polyatomic ions, and the -3 charge polyatomic ions, and just a little list of ones that you should also keep in mind. But if they are the last variable, then, or like the last element, then solve for it instead of depending on these oxidation numbers, because it's usually +1, it's usually +2. It's not always +1 and +2. However, for the common polyatomic ions, you should always depend on them when you see one come up. Okay, so let's start solving. Here you have to identify each of the following changes as either oxidation or reduction. Okay? E is an electron, so don't think it's another element. All right, in A, we'll see the charge of I. The charge of I is 0 because it's an uncombined element. It's not bonded with any other element. So it's 0 before the reaction, and after in the product it's -1. The oxidation is -1 because it's equal to the charge. So it decreased. It went from 0 to -1. When it decreases, it's reduction. For B, K before the in the reactants was 0 because uncombined element, and after the reaction it was +1 because it's equal to the charge. It gained 1, so it's oxidation. In C, it also gained 1. It used to be 2+, then it became +2, and then it became +3, which means it gained 1, which means it's the oxidation number increased, so it's oxidation. For the last one, it was Ag+, which means it had an oxidation number of +1, and it became Ag alone, uncombined, which means it became 0. So it decreased, the oxidation number decreased, meaning it was reduction. Okay, here we have to see which one was oxidized and which one was reduced. In A, Br before in the reactants was -1, and after the arrow it was 0. So it increased, which means it was oxidized. And Cl was 0 and it became -1, which means it got reduced because it decreased. That's how you classify which one is oxidized and which one is reduced. you just do that same thing. You see the oxidation number before and after. You see if it increased or not. And yeah, that's it. Okay, here we have two questions we have to solve. In HNO3, H is +1, as it states in Rule 3. N, we're going to make it X, and O is -2 because of Rule 4, which states that oxygen is -2. So then we start solving by Rule 5, which means you get the sum and you equal it to either 0 if it has no charge, or the charge if it has a charge. Here, it doesn't have any charge, so we'll make it equal to 0. So hydrogen only has one atom, so we put +1. Oxygen has 3 atoms, so we multiplied its oxidation number by 3 because it has 3 atoms. And X is unknown, so we add X and we make it all equal to 0 because it's uncharged. After doing simple math steps, you'll figure out that it's 5. The answer is 5. Okay, for KCN, CN is a polyatomic ion that was in the table that was a few slides ago, and its oxidation number is -1 because its charge is -1. And K is a group 1 element, so Rule 2 states that it has a charge of +1. In CN, we have to see which one is more electronegative. If you open your periodic table, you'll see that C is in group 14 and N is in group 15. So N is more electronegative. And because it's in group 15, it means its charge is -3. So now we only have C to figure out. So we put X, which is C, the oxidation number of C, and the oxidation number of N, which is -3. We multiplied it by 1 because N only has 1 atom, and we made it equal to -1 because of CN's charge. After that, we do simple math steps, and we notice that the oxidation number of C is +2. And that's all for today's lesson. I hope you enjoyed this video. Leave a like, subscribe, check out our other videos, and thank you for watching.